Welcome. My name is Brian Bonham. I'm a program manager on the Minecraft Education Edition team. So I work on content and curriculum development. And I have the pleasure today of having Wetsu from Piki Studios with me. So Piki Studios is the builder of the build challenge that we're going to be looking at today. Would you like to say a few words about yourself and Piki?
Yeah, kia ora, ko whetu taku ingoa. My name's Whetu. He mihi tēnei kia koutou, ko ngā akonga me ngā kaiako hoki. A big welcome to all the students or learners and educators here. We are Piki. We are from Aotearoa, New Zealand, and we love making Minecraft content for education.
I figured I'd like to put it on like a nice like landscape view while we talk. So we're going to talk a little bit about our build challenges. So we have this school year have returned to a monthly cadence with our build challenges. So we're going to have one of these every month. We have, I think, since maybe over the summer, I think is when we started this up again. So basically, each one of the challenges, we have a build prompt and a template world to sort of get you started. I actually am gonna jump over. I'll show you on the website. There we go. So on our website, you can find these resources in resources, and there is a section specifically for build challenges. So here are all the challenges, the featured ones. So the current one will be available right here, and then all of the past ones. I think we've got 50 or so of them now. Are available on this page in the same kind of format as this one. So each of these challenges has a title. There's descriptions as well as extensions that you can go and check out. I'm going to go back to game. All right. So the challenge that we have this month is a really impressive world with a bunch of valuable resources in it for teaching about logic gates through Minecraft Redstone. So I wanted to take a look at these with Wetsu. So this month's challenge, I'll tell you, is the Redstone Vault. So secure the vault inside of the Redstone labs using logic gates and computer science. Learn about logic gates, circuits, black boxes, and more while securing the vault with all of the treasure inside. Explore the 7 fundamental logic gates that make all computers work and see how they can be used in Minecraft. See examples of the logic gates, pistons, extenders, and even a fully functional 3x3 redstone gate. Make a simple lockable door or complex gate with sticky pistons and observers while learning about the basics of computer science. We also have several extensions available in there as well. But this is the world that we've got here. So we're going to go into, it looks like a big house, Wetsu. I guess we need a big house for a big vault underneath of it. Is that right?
Absolutely. The mansion of your dreams.
Nice. So we have a gentleman here that's going to talk to us and tell us a little bit about the challenge. So this is Redstone Labs, and your challenge, as we said, is you're going to make your own vault door. And let's head downstairs. We'll check this out and see what it looks like. What are we going to find downstairs? What's here?
So as we come in, we've got the entry room to your vault. This room is the engineering hub to this world. You'll notice our friend in front of us, the engineer.
Great.
He gives a little bit of a discussion around gates, redstone, and the idea of black boxes.
We can just click on these buttons right here, and the NPC will talk to us.
Absolutely.
And black boxes. And
so
redstone, for those folks that are new as well, this is sort of Minecraft's version of electricity. Yeah.
Absolutely, absolutely. Redstone doesn't exactly have an analog or isn't exactly the same as electricity in the real world, which is partly why we use the black box modeling in here. So if you go into one of the bays, this is a wire. Sure. And a wire, as you can see there, is when the input is on, the output is on. When the input is off, the output is off. If you toggle the black box, you'll see how we built this in Redstone.
So we can see what's going on behind the curtain.
Absolutely. So it's a simple lever, redstone to the light, which is what we'll call the output.
We're gonna keep it magic. All right, what else do we got here? So we've got we have a bunch of these different gates, yeah. to choose
So
from. Let's take a look.
there's 7, yeah, absolutely. There's 7 basic logic gates that make up the inside of all computers, including, not including the wire. So 8 all up. So we have 7 logic gates and the wire. The logic gates are combinations of how you can have 2 inputs, 1 or 2 inputs that generate a type of output. So for example, we could start off at number 2. And in this one, we have 1 input generating an output. And that input is when it is on, the output is off. Now we do understand, if we go back to the staircase, you'll see a little reminder here under the staircase that says when the lever is on when it's down, the lever is off when it's up. Now we've since found out that the United States of America have a slightly different way of turning lights off and on. However, that's just a little reminder for us. So down is on. And so when it's down, when the input is down or on, the output is off. When the input is up or off, the output is on. So this is called a NOT gate. In other words, it switches the input and output around. And the way we do this is by adding the redstone torch to the back of a block, which inverts the type of signal being sent by the lever. Again, this just to remind everyone, redstone doesn't really reflect electricity. So the idea of black boxing it is to give you guys a chance to understand electricity as inputs and outputs, which is, again, why we use this black box model. So if we go to OR gate, this time we've got 2 inputs creating an output. And it says that when any are on, and on means down, the output is on. When both are off, the output is off. And so this is an OR gate. So if input 1 or input 2 are on, the output is on. And so you can explore these logic gates, all 7 of them. So we have NOT, OR, AND, probably the 3 of the simpler ones. Then we've got a NOR gate and a NAND gate. These NOR and NAND gates are slightly more complex on the right there. In that they really test for whether both are on or off.
You have a favorite gateway too?
My favorite gate would have to be the XNOR. Or the XOR.
Is it the last one, this one?
Yeah, either. That checks when things are the same or different. I like this one because there's so much more things you can do with testing when things are the same or when things are different. You can imagine an entrance to a secret mountain lair where you have to have a series of buttons set in a specific way. And I think this is the most fun and the most complex. Yeah.
That's pretty cool. We can see what's going on back here. So we have, so this is the vault, and we'll let folks explore inside on their own, I think. You can see what treasures await inside there, but this is the outside of the vault. So this whole area, so we are in creative mode, so you're able to build here, and I'm flying around as well. So I also, just by pressing E for everything, we can find all of the tools that are available in here. We can find our redstone tools as well that are here. And we have some things in here, some examples, right, Watu?
Yeah, absolutely. In the middle area here, we've got some examples. So first go to the standard pistons. So these are just for people who haven't played Minecraft or are still learning about Minecraft, for educators that might need some visual explanations to help when their learners and students are teaching them about Minecraft. This is where they can come and they can see a standard piston, a sticky piston which retracts, pulling the block that it's attached to with it, and sticky piston with lime and honey, which are essentially extensions. They extend the the ability for the piston further than the one block it normally has. If we load the extenders, so these are more complex kinds of extenders. These are used to create doors that might need to be slightly more complicated. So you can see it pushes the block out twice, or two parts. This is a closed extended piston extender. So this means it is always open, and then we close it. And this is using, if you have a look at the back of that, the mechanics for it, this is using the NOT gate. So when it's on, it's off. When it's off, it's on.
It was a good teachable moment, I think.
Absolutely, absolutely. And then the open piston extender. This is again just the standard, but it gives the difference between an open and closed piston extender. And then lastly, if we click the blue pedestal again one more time, we'll go to an example of a slightly more complicated setup.
What do we have going on here?
It is a monster of redstone. But if you click the button on the left here, oh, on the you've just passed it. Rotate around. It's in the pink writing.
Oh, here?
No,
Right here?
no. No,
not that one.
On the side of the gate.
Over here?
Go around. Keep rotating.
Oh, there's the button. Oh, it has the sign on it as well. Look for the magenta pink sign on the side of it to get the machine starting. All right, so I'm gonna push the button.
That's it. And so you'll see.
Look at that! Look at that! It looks like a Rubik's cube or something. That was nice.
Absolutely. Now this machine here, you could potentially build this machine using this as a template model in the doorway, and then use attach, instead of having that button there, you can attach any one of the gates that you've learnt about to it, creating your own custom button system about how you want to open it. In this instance, we're clicking a button, but maybe you want to have two levers that need to be in different positions to open the gate. Or perhaps you need to have a NOT gate set up alongside a NOR gate, where one button has to be off and the other two have to be the same. And so you can create or as many combinations as you like, really, of inputs that will drive the little button here. And that will give us a chance to not only design ourselves in Minecraft, but learn something about some of the simpler parts or some of the fundamental parts of computer science, and how computers are built and made.
Love it. All right, I'm gonna turn that off. So this challenge will be available in November. I hope the walkthrough was useful for you. If you'd like to share your creations with the Minecraft education community, you can find us on social at PlayCraftLearn using the hashtag MinecraftEDU. So thanks very much to Wetsu for being with us today. I really appreciate your time.
No problem. He mihi anō kia koutou. I hope you have fun with the world, and I would love to see your guys' creations as well.
Awesome. Thanks so much. Bye-bye.
Yes.